If you are like Elon Musk planning to kickstart human existence on an entirely virgin planet, one thing you must work out is how to generate energy that will power all the systems you need. How will Musk provide energy for his Mars colonizers? Transporting fossil fuel and generating stations all the way to Mars is not practical, but the billionaire entrepreneurs come up with an innovative solution for a portable but powerful way to produce energy: nuclear reactors. How does Musk's nuclear reactor work? What is the capacity? And can humans not going to Mars benefit from it? Nuclear plants are not the most beloved human invention ever, and that is in no small part due to the highly publicized accidents involving nuclear power plants, like Fukushima and Chernobyl. Because of the health toll of these accidents, many people are skeptical when it comes to nuclear energy and will even protest if one were to be sited in their backyard. However, nuclear energy is a practical power source for many applications, including industrial and domestic uses. Elon Musk is a huge supporter of nuclear power, and he has legitimate reasons to be. In fact, he's surprised by the amount of public sentiment against nuclear reactors. Last year, while attending Code Conference in Los Angeles, Musk commented on Germany's decision to close its nuclear power plant, which would force the country to rely on coal-fired power plants. Musk clarified that he didn't ask for new nuclear plants to be built, but we should not be closing down the ones that are operating safely. Musk's position about Germany is supported by facts, because a study showed that increased pollution in the country likely caused 1,100 deaths last year. However, faced with the energy reality of Europe this year, Musk has called for a boost in Europe's nuclear energy output. He is referring to Putin's ongoing invasion of Ukraine. He tweeted that it's extremely obvious that Europe should restart dormant nuclear power plants and boost the output of those that are operational. While Europe plans to shut down 102 nuclear reactors at the end of this year, Russia is still responsible for about one-third of Europe's gas demand. The continent has come to rely on Russian natural gas exports as a transition fuel as countries move toward renewable energy. But the shift to renewables has not been fast enough for the EU to ease its reliance on Russian gas. That is not a good position for Europe as it tries to sanction Russia to weaken its ability to wage war with Ukraine. In fact, some member states are delaying sanctions because they can't think of another way to get the energy. If Europe truly wants to be energy independent and not produce carbon emissions during power generation, it may have to heed Musk's advice to produce more nuclear energy. Musk has even volunteered to eat food grown and prepared near a nuclear power plant on TV to convince people that there is no need to be in morbid fear of nuclear reactors or fatal radiation. Musk was even at Fukushima in Japan after the nuclear disaster. He was in Soma, which is just 37 miles or 60 kilometers from the center of the disaster, where he was setting up a solar power system. Evidently, Musk ate during his visit, and he is still here. Nuclear energy is practical for many reasons. Nuclear is the largest source of clean power in the US, generating 800 billion kilowatt-hours of electricity each year. This helps the country to avoid generating more than 470 million metric tons of carbon each year, which is the equivalent of removing 100 million cars off the road. This aligns with Musk's goals with his electric vehicle company, Tesla. Within SpaceX, where Musk's team is building the world's most powerful rocket, the Starship, nuclear energy is a commonly researched energy source. For example, the Starship might be designed to be powered by a portable nuclear reactor instead of other fuels. Nuclear reactors can also be used to generate power on Mars when the colony takes off. Musk is looking to settle 1 million individuals on Mars, and they need a reliable and sustainable power source from day one. While building the required space vehicle, SpaceX is also thinking of the bases that will protect Mars inhabitants from the harsh environment of the planet, which will need a power source. A portable nuclear reactor is easy to transport to Mars from the Earth. Musk can also transport nuclear fuels more easily than he could fossil-based fuels to support life on Mars. Imagine building a coal-fired power plant on Mars. That would be exporting our atmosphere-polluting ways to a whole new planet. It is no surprise then that when a group of engineers left SpaceX, they formed a company that works on nuclear reactors. This startup is known as Radiant, and its portable, zero-emissions power is the first of its kind. It works anywhere you need power, unlike traditional nuclear plants that are fixed in a location. The company is headed by Doug Bernauer, who used to research energy sources for Musk's Mars colony. While Bernauer is also sold on Musk's Mars ambitions and believes the best energy option for Mars is micro-reactors, he feels the mini-nuclear reactors hold immediate promise on the Earth. Radiant pulled in $1.2 million in funding in 2020 from angel investors, including Charlie Songhurst, Hank Vigil, Josh Manchester, and Tom McInerney. Tom McInerney had high praises for Radiant. He said, "The innovative and ambitious team at Radiant has expertise from SpaceX as well as impressive nuclear industry credentials. They have what it takes to bring new clean energy solutions to market, and I'm excited to be a part of their journey." The company has already received provisional patents for its groundbreaking advances in portable nuclear reactors. One of these technological advances decreases the cost and time needed for refueling the reactor, and the other enables greater efficiency in the heat transport from the reactor core. Radiant also signed an MOU with the Battelle Energy Alliance, which manages Idaho National Laboratory. The agreement was to co-develop and test Radiant's new nuclear technology. The California-based company says it has a competitive advantage over its competitors because of its team's expertise in nuclear technology, rapid product iteration, and commercializing complex technologies. Unlike their competitors that staff their companies with people with academic backgrounds, Radiant boasts engineers making an engineering product. Radiant's micro-reactors are very suitable for operations in remote locations like Arctic villages and remote military bases. Most of such existing locations depend on fossil power generators. They face logistic problems in transporting equipment and fuel. It could even be a matter of life and death. Take, for example, the US military. A 2018 US Army report said about half of the 36,000 casualties in the 9 years during Operation Iraqi Freedom and Operation Enduring Freedom II occurred from hostile attacks during land transport missions. However, Radiant's micro-reactors produce clean energy which can last years without having to add new fuel. Even when you refuel, it is easy to transport the fuel. The mini-reactors can also work underground. Radiant's reactors can produce over 1 megawatt, which is enough to power about 1,000 homes for up to 8 years. If you connect multiple micro-reactors, you can produce enough to power an entire town or military base. The micro-reactor fits in a shipping container and can be easily transported by air, ship, and road. Radiant's micro-reactor is way safer than conventional nuclear reactors. It leverages an advanced particle fuel that does not melt down and withstands higher temperatures when compared to traditional nuclear fuels. The use of helium coolant greatly reduces corrosion, boiling, and contamination risks associated with more traditional water coolants. Radiant is simplifying its design and development work by using a very well-established and extensively tested fuel. The company points out that the Department of Energy has spent hundreds of millions of dollars testing the fuel. While Bernauer is already working with the US Department of Energy, his company is also teaming up with the Department of Defense. In fact, the Department of Defense is set to become Radiant's biggest client as it seeks to provide power to its numerous bases located where it's impossible or difficult to access electricity. Due to the risks mentioned earlier, the Department of Defense wants to reduce and, if possible, eliminate the use of diesel and other fuels in remote areas. This will reduce the military's budget for logistics drastically. Radiant's micro-reactors are extremely suitable for the Department of Defense's energy needs. Bernauer says he is targeting a system that you can set up within 72 hours of taking delivery of the micro-reactor's modules. Speed is what the military appreciates. The Department of Defense is also banking on the scaling ability of Radiant's micro-reactors. It can easily move units between bases to meet changing power requirements. Bernauer says you can move a Radiant micro-reactor just a week after commissioning it. Let's hear what you think of micro-reactors working on Mars in the comments section below.